Matrix, this evening we had said that we were going to talk about trigonometry again. Last week we spoke about trig basics in our Thursday lesson, and we said that this week we were going to speak about the graphs, and we're going to try and speak about a little bit of 3D trig. So what I've tried to do for you this evening is I've tried to find papers where they have asked sort of more difficult questions on trig graphs and on 3D trig. So those are the ones that I want to do with you. Unfortunately, these papers are, well, not unfortunate, but these papers are available online. So if you do want to know where it comes from, I can certainly tell you that. But in my opinion, I just sort of thought it would be a good idea to do something that was sort of like really difficult. And then if you got other things that were easier, then good for you. Okay, so this is the question that I have selected. It says in the diagram, the graphs of f of x equals. I really appreciate you taking over for me for a couple of seconds there. Okay, guys, let's get on with this. And yeah. All right, so as I was saying before the power went off, in the diagram, we've got the graphs of f of x equals sine x minus 1 and g of x equals cos 2x that are drawn from the interval from minus 90 to 360. The graphs f and g intersect at A. They also intersect in another place as well. They don't talk about that though. And they've told us that the point B, which is down here, is the coordinates are 360 and minus 1. All right, Kat, you know what I'm just thinking? What I'm going to do is I'm going to turn off my video just to make it more stable, because I'm having problems with that inverter. But anyway, all right, so the first thing that they want us to do is they want us to write down the range of f. Now, before we get into that, we need to make sure that we understand what it is that we are looking at, all right? So when they say to us, we've got a graph y equals sine x, they've made all these changes to it. It's actually the graph y equals a sine b x plus p plus q. Those are all the different things that they can change. So they can change a, they can change b, they can change p, and they can change q. What does a represent? What are they changing about the trig graph when they change a? I know. What do they mean when they've changed a? Amplitude, exactly. Right, so they've changed the amplitude of the graph. What does amplitude do to a trig graph? When you change the amplitude, what does it do to the graph? Any ideas? What does it change about the graph when we change amplitude? Okay, so it's just, I think also all their answers are only coming to me, Kat. I don't know if you want to just change that setting so that it, there we go.
I changed it. Oh, there we go.
Oh, did you? Oh, okay. All right.
Yeah.
Okay. Sorry. Thank you so much. Okay. So it changes it. In other words, what we have is a vertical stretch. All right. So in other words, our minimum and our maximum become bigger. So the graph is stretched vertically. All right, very important that we know this so we know how it's, yes, vertical stretch, yes, 100%. When we change this letter over here, B, what does that change about the graph? The width of the wave, okay, absolutely. So what do we call B? Which here, Paul? There's a word for it. B changes the period. Yes, Isona, quite right. It changes the period. Okay, so that is a horizontal stretch. Okay, so if B is a number between 0 and 1, then the graph is stretched out. If B is greater than 1, then the graph is going to be compressed. Okay. Okay, cat, no problem. Just give me 1 second. Sorry, guys. This is where hang on. There we go. Load shedding just causes so many problems for us, doesn't it? It's such a pain in the backside. Okay. All right. So period, when we change the period, we're changing how often the graph repeats itself. Okay. So if B is a value between 0 and 1, the graph repeats itself less frequently than it normally would. And if B is greater than 1, then the graph repeats itself more frequently than it would. So when B is greater than 1, the graph is going to be compressed or pushed together. And when B is a value between 0 and 1, then the graph is going to be stretched. What do the letters P and Q represent? What does P change? What does P change? So if I was to say something like, I have a graph h of x, there we go, quite right, can you see it? Left and shift right, yes, that's true. Range A and P is domain. So P is what the others were saying, Boyd Shepherd. So in other words, it is shift left and right. So it's horizontal translation. Okay, so horizontal shift. Okay, so if I have a graph h of x and I say that it is equal to sine x plus 30, what am I saying has happened to my sine graph? It has been shifted 30 degrees to the left or right matrix. So h of x equals sine x plus 30 means that my sine graph has been shifted 30 degrees to the which side? To the left, absolutely. Okay, so x plus 30 means it's shifted 30 degrees to the left-hand side. So if it's a plus inside the bracket, the graph has been shifted to the left. If it's a minus inside the brackets, the graph has been shifted to the right-hand side. What does the letter Q represent? This is our vertical shift. So in other words, our shift up and down. Quite right, Isona. Okay, so shifting it up and down. So if Q is positive, then the graph has been shifted above the x-axis. If Q is negative, then the graph has been shifted below or down underneath the x-axis. All right, so we need to know all of these things so that we understand the information that they give us. So if we now go back and have a look, and I believe you guys are not allowed to use highlighters, which I think is a real pity because I like highlighting my graphs. So I'm just going to do that very quickly. In the meantime, I want you to have a look at the equations and think about how these graphs are different to the original functions. Okay, so to the original sine x function and the original cos x function. What's been changed in these two? Can anybody tell me what's different in the f of x graph? What's been changed? According to what we did here on the left. So f of x is the original sine graph, but it has been shifted 1 unit down because it's the graph sine x minus 1. Does that make sense to everybody? So it's been shifted 1 unit down. Okay, everything else is still the same. Same amplitude, same period. It hasn't been shifted left or right. It's just been moved 1 unit down because of the -1 at the end. Okay, in g of x, I've got cos 2x. So what's changed there? Cos 2x, what have they changed? What does cos 2x mean, matrix? How has the original cos function been changed? The 2 is in front of the x. So that's like the letter B over here, right? The B that I highlighted in green in the beginning. Okay, so this B over here. Okay, that's what they've done. They've changed the number in front of the x. They've changed the period of the graph. Here, in this situation, B is greater than 1, okay, because it's 2. So the graph has been compressed. Okay, it now repeats itself twice every 360 degrees instead of once every 360 degrees. Okay, so that's important because they could ask you questions like that, because they could ask you about what is the new period, or, you know, whatever the case might be. So you've got to know these things in order to be able to answer those questions. The first thing that they ask us about in 6.1 is the range of f. Okay, so I'm not going to give you guys the answers. I want you to tell me what you think, okay? So in 6.1, what do you think the range of f is? What does the word range mean? The range is our set of what values? Y values, quite right. Okay, those are our outputs. Right, so this is going to involve our maximum and our minimum. What is our minimum in this case? So we're looking at the yellow graph. What is our minimum output? I remember the last time, Blankenberg, you told me your first name, and unfortunately I've forgotten. What's your first name again? Kaylin. Okay, Kaylin, let's just change your name. Kat, will you just change her name to Kaylin? Okay, so Kaylin, I'm really, really pleased that you are giving me answers here, but -90 is not a y value, it's an x value. Okay, so your second answer was correct. Okay, so the minimum in this case is going to be, you think you just put the wrong sign, it's going to be -2. Okay, Kulani, that's quite right. But Shepo is our maximum 2 though. Our minimum is -2, quite right. What's our maximum? Remember, our original sine function has been shifted 1 unit down. So it's, there we go, Kaylin, quite right. Okay, good. 0 is the maximum. Lovely. Okay, so the range, either we can write it like this. Y is an element from the smaller number on the left. Oopsie, and I'm using the wrong brackets here, which is why I don't like writing it with brackets. But anyway, never mind. Y is an element from -2 to 0, both included. Okay, or I could say y is greater than or equal to -2, but smaller than or equal to 0. Okay, no problem, Wojciech. No problem at all. Okay, good stuff. So now we've done 6.1. We've written down the range, our set of y values. 6.2 now. they want is, I'm just going to shift this over a little bit because obviously half of it's sticking out. Write down the values of x in the interval from 0, -90 to 360 for which f is decreasing. So what does the word decreasing mean? What does the word decreasing mean? Grade 12s? Specifically with regards to functions, what does the word decreasing mean? It has a very specific meaning. What does it mean? What does the word decreasing mean? Specifically with regard to functions. Like we all know when something is decreasing, it's getting smaller. But what does it mean as far as functions are concerned? Isona, you got any idea? What does decreasing mean? There we go. The gradient is negative. Quite right. Okay, so it means a negative gradient. Lovely, Kaylin. Well done. Okay, so now we've got to go and have a look. Where is the gradient negative? So in other words, where are we going? Downhill. Right. So the graph that we need to be looking at is our graph of f. Okay, so that's going to be our yellow graph. That's the one that we're looking at. Where is it decreasing? Okay, well, if we were standing over here and we were walking in that direction, we'd be walking uphill until we get to 90. And then once we get past 90, we're now walking in that direction. So we're going to be walking downhill until we get to that over there, which would be 270. And then we would be walking uphill again. All right, so it's decreasing between 90 and 270. Okay, so the values of x for which f is decreasing is going to be when x is greater than 90, but smaller than 270 degrees. Okay, how does that make sense? Is everybody happy with that? Are we all good? Thumbs up, thumbs down? Just want to check in with you. All good. Okay. All right. And now the real reason why we are doing this question, okay, because of question 6.3. So this is a bit of a nasty one. What I'm going to do is I'm going to take it and I'm going to copy it and I'm going to put it over here. All right. And the question in 6.3 is P and Q are points on graphs G and F respectively. So P is a point on G and Q is a point on F, such that PQ is parallel to the y-axis. So what sort of line is PQ? If it's parallel to the y-axis, it must be a what sort of line? What do you guys think?
Straight line. I think it's a straight line.
It is a straight line. You're quite right. It is a straight line. But is it diagonal? Is it horizontal? Is it vertical? Okay, so if it's parallel to the y-axis, it has to be a vertical line, okay, in order to be parallel to the y-axis. Okay, does that make sense to everybody? It has to be a vertical line if it's parallel to the y-axis. Okay, so what we're going to do is we're going to take this vertical line and we are going to move it a little bit, all right? So it's either between, so it's somewhere between A and B. So either it's here, or it could be there, or it could be there, or it could be here, or it could be there. Somewhere between A and B. we have this vertical line, okay? What do you notice the closer I get to A? What happens to the length of my line? The closer I get to A, what happens to the length of my line? So in other words, from here to here, compared to from there to there. Can you see the closer I get to A, the shorter the line becomes, because A is a point of intersection. So in other words, the length of PQ changes, right? So it can be short or it can be a little bit longer. There would be the P and there would be the Q. If I was down here, PQ would be shorter again. If I went up here, then PQ would become longer again. Right, so the length of PQ changes between A and B. It's not one constant length, okay? And that's because of the shape of the graphs. Okay, so the graphs get closer together and then they get further away. So as the graphs get further away from one another, the length of PQ increases. As the graphs of G and F get closer to one another, so the length of PQ decreases. So now what they want us to do is they want us to work out the value or values of X for which the length of PQ will be a maximum. Now, this becomes a difficult question because, well, any questions about min-max are generally challenging, but we're not used to doing maximums and minimums in trig functions. So it has to be something with which we are familiar, okay? Because they're not asking us questions outside of our syllabus, right? So it's got to be something that we know. So if we're talking about the maximum length of a line, what would we normally do? I mean, if our expression was quadratic, what would we do about a maximum? How would you find a maximum if your expression was quadratic? You could use derivatives, okay, but we're not used to working with derivatives with trig functions, okay, but yes, we could use derivatives. What else could we use? Specifically with quadratics. Ah, there we go. We could complete the square, all right, which we would try not do, hey, Tyler, because that is a bit of a nightmare. So yes, we could complete a square, quite right. What else could we do to find a maximum or a minimum? There we go, Kulani, minus b over 2a. All right, so if we've got an equation, right, then using minus b over 2a is the easiest way for us to find the input, okay, at which our maximum or minimum occurs. And then once we've got that, we can then work out what the corresponding y value is. Now here, they are asking us to determine the values of x. So they're asking us about the inputs. They're asking us about the x values. All right. So how are we going to find the difference or the length of PQ in terms of what we've got? Remember, when we work with a vertical line, the length of the line is the y at the top minus the y at the bottom. So PQ, the length PQ, is the y at P minus the y at Q. Remember, P was at the top and Q was at the bottom. So P, if we recall, was a point on G. The equation of G is cos 2x. Minus the y on Q. Q was a point on f of x, so that's sine x minus 1. So now because that is a binomial, I've got to put it in brackets. All right, so now I end up with, I'm going to take the brackets out, and I've now got cos 2x minus sine x plus 1. So I've got the length of PQ in terms of the graphs that I've been given. But now, is there something here? Let me go and see if I can grab, hang on, this is what I want, even though it's got a funny thing on it. I'm just going to go and grab this and slap it over here. okay? What do I see in my expression that is familiar to me on my formula sheet? And remember, this formula sheet is silly because that's supposed to be cos, but anyway. What can I see in my expression for PQ that's also on my formula sheet? Exactly, Kulani. Okay, I've got a double angle. I just want to write to a student, just 1 second. There we go. Okay, so we have got a double angle, right? Now, I don't know, those of you that have been at Watobe for sort of most of this year would have heard me say this. But just because I said it doesn't mean that you know it and you understand it, right? When we are working with an expression or with an equation, it is our middle term that dictates how we should write our double angle. So because I've got sine x in the middle here, I want to write cos 2x as 1 minus 2 sine squared x. So in other words, in my next step now, just get rid of this off the page, I am going to rewrite cos 2x as 1 minus 2 sine squared x minus sine x plus 1. I'm just going to collect my like terms together, and this gives me minus 2 sine squared x minus sine x plus 2. Okay, this expression is quadratic. Okay, this expression is quadratic. Okay, it has a sine squared x and a sine x and a constant term. So if I want to work out the minimum or the maximum, I'm going to do as Kulani said. All right, and I'm going to use minus b over 2a. Okay, so in this case, it's sine x equals minus b over 2a. What is the value of b? What is the value of b in this case? I'm just going to move this diagram down. What is the value of b? The value of b is minus 1. Okay, so it's the coefficient of the sine x term. Okay, can you see there? Boichepo, that's right. Okay, b is equal to negative 1. Okay, so remember a is the coefficient of the sine squared x term. Okay, b is the coefficient of the sine x term, and c is the constant. Okay, so in this case, it would be negative 1 over 2 times negative 2. Okay, which would give us a negative times a negative divided by a negative would give us a negative as an answer. So it would give us negative 1 over 4. So in other words, sine x is equal to negative 1 over 4. All right, so that's a ratio, isn't it? We've got, I'm just going to write it over here as well. We've got sine x equals negative 1 over 4. Now what we've got to do is we've got to go and find out where this is happening on this graph. Okay, so when y or outputs or our ratio is a negative 1/4, that is when the length of PQ will be at a maximum. All right, so what we can do is we can now calculate the angles where this is going to happen, right? What I would recommend at this stage is calculating your PAA. Now, for me, it's going to be a bit difficult because I'm sitting here in the dark, but I want you to calculate your reference angle. Oh gosh, I can't see a thing here. Are you guys calculating your reference angle? go. All right, so I've got my phone on, calculated a reference angle. What are you guys getting? 14,48. Yes, brilliant, brilliant, brilliant. Thanks, Kat. Okay, so 14.48. Now, just hang on to that for a second, okay? Let's go and have a look, all right? In which quadrants are we working if we're working between A and B? In which quadrants on the Cartesian plane are we? In which quadrants are we if we are between A and B? Where are we on the Cartesian plane when we are between A and B? One and four. Okay, so Kaylin, all right, when we get to 90, then we're in quadrant number 1. Between 90 and 180, then we're in quadrant 2. Between 180 and 270, then we're in quadrant 3. And between 270 and 360, then we are in quadrant 4. Okay, so we're either in quadrant 2 or quadrant 3 or quadrant 4. Right. So now, what is this? It's sine x, okay, equals -1/4. All right, so it can't be quadrant 2. All right, so now we're going to concentrate on quadrants 3 and 4, where sine x is going to be negative. What reduction formulae do we use for the third and the fourth quadrants? In quadrant 3, we use the reduction formula. So for quadrant, this is not something that you would write down, but I'm just putting it on the page. In quadrant 3, you would use the reduction formula, 180 plus, isn't it? Okay, good stuff. In quadrant 4, we would use the formula, reduction formula, 360 minus. Okay, so what we need to do here with our value of x is we need to say either x is going to be equal to 180 plus our 14, what did you guys say it was? 14.48, there we go. Or x is going to be equal to 360 minus our 14.48. Okay, so there are 2 different places where the length of the line will be at a maximum. Either, so this would be at 194, where's my pen? 194.48 degrees, or over here at 360 minus would be at, 1 second. Are you guys getting 345.52? Okay, all right, lovely. Excellent. Okay, what did you think of that question? Does it make sense? Are we all good, guys? Makes a lot of sense. Oh, good. Oh, I'm so glad, Kalani. That's great. Nice, Pochepo. Thank you. Okay. All right, let's go on and do the next question. Okay, so this is also a little bit more difficult. Don't worry about that one now. I just want us to focus on this. Okay, so this is a 3D trig question, and the reason why I selected it is because you can see here, question 7.3 was out of 7 marks. So that's a lot. So that's why I wanted to do this question with you guys today. Okay, so in question 7, it says to us, the diagram below shows a solar panel, A, B, C, D, which is fixed to a flat piece of a concrete slab, EFCD. Right, let me just move that down. So EFCD is that bit in the horizontal plane. ABCD and EFCD are two identical rhombuses. K is a point on DC such that DK equals KC, and AK is perpendicular to DC. The other thing that has happened is that AF and KF are drawn, and they have also told us that ADE equals CDE equals 60, and AD is X units. So fortunately for us, they put all of that information onto the diagram. So now we can go and have a look at the questions. So in the first one, in 7.1, they want us to write down AK in terms of X. Okay, Sauna, you now asking a question about the previous thing. No problem. Let me just... When they want you to maximize the length of a vertical line, Sauna, then it's the Y at the top minus the Y at the bottom. Okay, so that's for a vertical line on a function or in functions. Okay, then it would be the Y at the top minus the Y at the bottom would give you the expression for the length of the line. And then you can maximize or minimize the length of the line based on that. So if the expression for the length of the line is quadratic, then it's easier to use minus b over 2a, especially in this case because we were working with sine squared x. All right. Otherwise, yeah, you could complete the square. If it was possible to use calculus, you could derive, make it equal to 0, or yeah. I suppose the other alternative would be, completing the square, but we're not going to want to do that with what we had. Okay. All righty, Sauna, let's carry on with this question. All right, so AK in terms of X. So if we go and have a look at AK, what do we know? So we always got to ask ourselves, especially with these sorts of questions, because oh, no problem. Before we just jump into that, I just want to put down something over here for you, by the way, when it comes to 3D trig. Okay, sorry, I forgot to mention this. So when it comes to 3D trig, you need to ask yourself one of two questions, right? What triangle are you working in? Is your triangle right angled? Okay, so is the triangle right angled? And if the triangle is right angled, then what you're going to do is you're going to use your basic trig ratios. So when I say your basic trig ratios, I mean the trig ratios that you learned when you worked with right angled triangles back in grade 10. So in other words, sine theta is opposite over hypotenuse, or cos theta is adjacent over hypotenuse, or tan theta is opposite over adjacent. Also, if you are working in a right angled triangle and they want you to calculate area, you can say area is equal to half base times height, because your base and your height are the two sides that are adjacent the right angle. Okay? Or is the triangle not right angled? So here is not right angled. So if the triangle is not right angled, you cannot use basic trig ratios, right? So we either have to use the sine rule, and we can use the sine rule to calculate a side or an angle, depending on what they ask us and give us. Or we would use the cosine rule. And again, we can either calculate a side or an angle, depending on what information they gave us and what they were asking us to do. And if they asked us to calculate the area of the triangle and it was not right angled, then we would use the area rule. Okay, now the cosine rule, the area rule, and the sine rule, as you guys well know, are on your formula sheets. Okay, all you've got to be able to do is sew into them. Okay, so now let's go back up to this question over here and determine AK in terms of X. So AK is a side in a triangle. Is the triangle right angled? Is the triangle right angled? It is, because it's triangle AKD. Right, so if we want an expression for AK in terms of x, x is the hypotenuse of triangle AKD. So what we would do here is we would use our angle that we've been given, so 60 degrees. AK is opposite, and x is the hypotenuse. So we'd have to use the sine of the angle. Okay, so in 7.1, we would say that the sine of 60 degrees is opposite AK over hypotenuse, which would be x. So now we want to make AK the subject of the formula. So AK would be equal to, and the sine of 60 is root 3 over 2, isn't it? So root 3 over 2 x, like so. Does that make sense to everybody? So there I used my basic trig ratios because I worked in a right angle triangle. Are we all good? Yes, lovely. Okay, now they want us to write down the size of KCF. So in other words, this angle over here. Write down the size of KCF. How big is it going to be? Remember the information they gave us in the beginning. They told us that ABCD and EFCD are identical rhombuses. So how big does that make angle C? Not 60, Tisha, unfortunately. Remember, a rhombus is a parallelogram. And parallelograms have got parallel sides. So in other words, DE is parallel to CF. So the angle at D and the angle at C, those would be co-interior angles. So KCF would be 120 degrees in size. Does that make sense? Everybody happy with that matrix? Okay. So now let's talk about question 7.3. Cool boy, Chimple. Thanks, Kulani. If it is further given that AKF, so where's AKF? AKF. So in other words, this angle over here, AKF. If it is further given that AKF, the angle between the solar panel and the concrete slab, is Y, determine the area of triangle AKF in terms of X and Y. All right. So AKF is this triangle over here. Okay. They want the area of the triangle. Is it a right angle triangle? Is AKF a right angle triangle? No, it's not. Okay. Remember when we work with the area rule, right? Because it's not right angled, we have to use the area rule because it's not a right angle triangle, so we've got to use side angle side. So if they've given us this angle over here, then we want side AK and we want side KF in order to be able to work out the area of triangle AKF. We've already got AK, all right? We've got that from 7.1. So now we need to know the length of KF. We've just written down that KCF is equal to 120. So we can see that side KF is opposite this angle, and they've told us that DK and KC are equal to one another. Because it's a rhombus, it means that DC and CF would also be equal to each other. Does that make sense to everybody? Okay, all right. So which triangle do you think we now need to work in, and what rule do you think we need to apply? Which triangle do we need to work in, and what rule do we need to apply? Kat, they said to us in the beginning here that DE, hang on a second, isn't DCFE is a rhombus. So doesn't a rhombus have parallel sides? So that's why this would be 120. And then that would be 120. And that over there would be 60. Sorry, not this bit here. Okay, does that make sense to you?
I get it.
Okay. So what we see, we want side KF because we've already got side AK. We want side KF. KF is a side in a right angle triangle. Now, all of these rhombuses are equal, so all their sides are X. So this over here, this has to be X over 2. And this one over here also has to be X. Does that make sense to everybody? So what we would do is we would end up using the cosine rule, right? So what we would have is KF squared is equal to KC squared plus CF squared minus 2 KCCF cos 120. So KC is X over 2 squared. CF is X squared minus 2 times X over 2 times X cos 120. Sorry, it's a little bit squashed here. Okay, so this is going to give us X squared over 4 plus X squared minus X squared cos 120. Okay, so now if that was over 1 times by 4 times by 4, so this is going to give us what? 5x squared over 4 minus x squared cos 120. So now cos 120 can be reduced, can't it? So that would be reduced to negative cos 60. All right, so this is going to give us 5x squared over 4 minus x squared multiplied by, now cos of 60 is going to be a half, isn't it? The cos of 60 is the same as the sine of 30. So multiplied by negative 1 over 2. So this is going to give us 5x squared over 4 plus half x squared, which means we are going to end up with times by 2 times by 2. So this gives us 5x squared plus 2x squared is 7x squared over 4. Okay, remember this is kf squared. So now when we want to take the square root on both sides, we're going to end up with kf being equal to root 7x over 2. Now that we've got kf, we can use our area rule. So what I'm going to do is I'm just going to move this out of the way. Now we're going to use our area rule. Okay, so the area of triangle AKF, okay, is going to be half, and then it's either side, so it's AK, so half times AK times KF multiplied by the sine of the included angle, which in this case is Y. All right, so now I know that AK, I got that in the beginning in 7.1. So AK is equal to root 3 over 2x. So times root 3 over 2x multiplied by KF, which is root 7x over 2 multiplied by the sine of Y. Okay, so what is this going to give me in my numerator? I'm going to end up with root 21 x squared sine Y all over 8. Okay, and that's the most that I could possibly wish to simplify this expression. Okay, so there we go, 7 marks. And look at that, our hour is gone. Is that okay, Matrix? Is it making sense? Yes, oh good. What doesn't make sense, Kulani? Kulani, we don't have time for me to explain from the beginning, unfortunately. Where did I lose you?
Ma'am?
Yes.
You lost me when you said 5x squared over 4.
Okay, so did I lose you when I got to this line over here, where I'm highlighting in yellow?
Yes.
Okay, so here I'm adding 2 fractions together, Kulani, but they've got different denominators. So I multiplied this 2 over here with 2 so I could get 4. So what I did to the bottom, I did to the top. So that's why I ended up with 5x squared plus 2x squared over 4.
Oh, okay.
Okay, all right, and that's where the 7x squared over 4 came from.
Oh, okay.
Okay, and then I took the square root on both sides, and that's why I ended up with root 7x over 2.
2.
Yes.
Okay.
Does that make sense now?
Yes.
Lovely. And then do you get the bit about where I subbed into the area rule?
Yes.
Okay, all right. So you know where all those values come from.
Yeah. Thank you.
It's a pleasure.